All right, so we've got page 116, and we've got this problem here. Now notice we're doing something a little different here. We're not finding the pressure, we're finding the flow. So just fill in what you know on the table on page 116 there, and then we'll figure out how to get what we don't have on the table. There's 20 psi required at the hydrant. It's a pretty common number there. I think we'll ignore velocity head. So it's 20 psi is kind of this threshold number, that you need to maintain in a water distribution system. You don't like to go below that for fear of having a vacuum somewhere that could pull contaminants into the system.
What's the 920?
920, that's how many feet of pipe there is.
Oh, okay, right.
Okay. So y'all getting to something like that, 320 total for the reservoir, and then I got 286.2 total for the hydrant. Y'all okay with that? Because it's 20 psi, that's 46.2 feet. Add that to the elevation of the hydrant. So what I've got there is the total energy in the reservoir and then the total energy required at the hydrant is what I've got there.
Can it be more than 20?
It could be, but the minimum acceptable level is 20. Okay? So we're going to design it so it's got so it has 20 psi at the hydrant. Okay. And if we get more than that, it'll be okay. So y'all good with that? Any questions? All right. So what we can get to next here is how much head loss we can tolerate, okay? So we got 320 at the reservoir. We've got to have at least 286.2 at the hydrant. So if we get the difference there, which I think is 33.2. Oh, thank you. Yeah, it's 0.8. 33.8. That's the maximum head loss we can have. Okay? Everybody okay with that? Now that's the total head loss you can have in that run of pipe from the reservoir down to the hydrant is 33.8. All right. Now I want to go to the chart is what I'm going to want to do here eventually. So the chart, of course, is per 100 feet. So if I divide that by 9.2, what I'll get is the head loss per 100 I can tolerate, so to speak. Okay? So that's 3.67 feet per 100 feet. Everybody okay with that? So what I've got here is that I can have 3.67 feet of head loss per 100 feet of pipe. And when that water flows down that pipe, by the time it gets to the hydrant, it'll have a total head loss of 33.8. And that will get me to the total amount of energy that will get me 20 PSI at the hydrant. Okay. You all good with that? So if I want to know the flow, what's the next thing I'm going to do? Go to page 108. It's 8-inch pipe, right?
Mm-hmm.
Yeah, 8-inch pipe. So start looking for 3.67.
And you'd want to get closest, but not over, right?
Yeah, I think so. And yeah, this is one of those things where understand that this isn't perfect. Don't waste your time like, carving it down to the 10th of a GBM or something. That's silly. And yeah, I'd go under, not over, is what I do on this. So we got 8-inch pipe. We're looking for 3.67. We got 550 and 600 on either side. Okay, so what we're looking for here is 3.67. And then when I look at that, what I'm seeing is for 8-inch, for 550, I've got 3.51. And then for 600, I've got 3.83. That's what I'm pulling off the chart.
For an 8-inch pipe?
Yeah, I think so. Am I good? Yep. Oh, no, I'm getting velocity. My bad. Yeah.
Right.
I'm screwing up.
So
Yeah,
1100, right?
Yeah, right. Okay, my bad. I was pulling the wrong column. I was pulling velocity. Looked about right, and then let's try that again. So 1,100 gallons per minute. There we go. 8-inch, 3.52. And then 1,200 is 4.14. There we go. My bad. It's 8-inch pipe. All right, so, I would say if someone says, hey, if I pull that hydrant down to 20 PSI, what flow am I going to get? I'd say about 1,100 gallons per minute is what I tell them. Okay. And I don't know, I've not been a firefighter or anything, but I think they have pressure gauges, they try and track what they're doing when they start pulling water. They don't want to pull a vacuum in the system when they're fighting fires. They definitely don't want to do that. Okay. So we okay with that? Okay. So that's another thing you can do with these tables is, for a given situation, you can predict what kind of flow you can get out if, just by looking at those head loss charts. So we're using the tables, but we're doing it a little differently than what we were doing before. Okay. Okay, how about this next one? Let's just design a pipe that'll do this, okay? So same parameters, so to speak. We got, same sort of stuff given. But this time we want to pick a pipe for a given flow rate is what we want to do. We need 2,100 gallons per minute. And that might be based on the types of buildings that are in the area, wood frame versus masonry and that sort of thing. You got criteria for fighting fires for different types of buildings and the density and all that. On the same page down, the one at the bottom of 116. Okay. So I'm getting the same table that I got before. And I'm going to get the same head loss per 100. It's 3.67 because it's the same situation. All right. So what are we going to do this time? You got 2,100 gallons per minute this time.
Find something that's gonna have a head loss at a flow of 2,100.
Yeah.
No less than 3.67 head loss?
Well, no greater.
Or is it greater?
Yeah, right. We're on 116. So we're at 2,100 gallons per minute.
You use the 8-inch again, or?
I don't know.
Or no, I'm sorry. It's
Yeah.
gonna be greater than-
Yeah, right. That's the thing, because you want less head loss. Yeah, and in between a 10 and a 12, I think, if you dial it in a little closer. Yeah. Yeah.
It doesn't say 2,100 gallons per minute on it.
We're on the bottom of 116.
Oh, there it is.
All right. So I'm getting, yeah, between 10 and 12. Now, if you're doing, doing engineering type work or whatever, do you go with the big thing or the small thing if you're going to design, if you want to be safe? Big, yeah. Go up, so 12 inch, see. I'm not going to give them a 10-inch pipe because I won't get them enough
Pressure.
yeah, and especially for fighting fire, I'm not messing around with that. I'd go 12-inch. Okay, it's close to it's.
Could it also cause for more hammer in the pipes and more suction oil collapse things?
Well, mostly it's about pressure. That's the main thing I'm looking at. And if I can't get the pressure the fire department needs at the hydrant, I'm gonna be darn sure they get what they need. Now this is kind of close. I mean, that you're gonna pay more for this. If you're really on a budget, you might kind of scratch your head on this one and say, well, could we get by with a little less flow? But this kind of stuff, liability type stuff, where someone's house might burn down. I'm not gonna err on the side of caution. I guess that would be the way to say it. So I'll go with the bigger pipe. So I go 12-inch on this one. So we okay with that? We got any questions on that one? So you can do more with this than just find pressures. I mean, you can start finding flows and pipe sizes and all that. Just what you're doing there, you're kind of backing into what the head loss can be. So we're totaling up this column and getting 320. We total up that column and we get 286.2. So we know the head loss will be subtracted from the one on the left to get the one on the right. That's what we're doing. Okay. All right. Okay, let's try this again, but let's have C at 140 this time. So once you get that table filled out, we're still at the same kind of criteria that we have been. And see what we could do with this. So in this one, we want to find the flow. That's 140. Well, get the chart filled in first. That's kind of the idea, yeah. We're gonna have to figure out how to use that. So I just get the chart filled in first. Okay? Look at the left side, look at the right side. Then we'll kind of work into how to use that. But you're right, that's kind of the idea.
Now, unless it says
Yeah, it's zero because we're looking at the top, an open reservoir, who's going to pressure?
there's no pressure.
There's no going to pressure. That's what I'm saying. Then we do the same thing for the hydrant. You got all the information for the hydrant. Are you doing all right? So just go through those calcs, get the left side and the right side. All right, Jesse. Yeah, it looks great. Right, so, well, you find it by filling in this column for the hydrant, and then we'll take the difference, and that's how we get the difference. So this one's a little different than the ones we did.
Oh, so just take this.
Yeah, right, fill it in there.
Okay.
And then you can kind of back into what the head loss is.
Right.
Yeah, thanks. So yeah, it's 3.67 and then 3.67 feet per 100. That gets us about 1,100 gallons per minute, right? Close enough, maybe a little higher, but. All right, now that's for C of 100, right? That's what that chart's built on. Y'all okay? Yeah, so.
Can you go to the pressure head for the hydrant?
Yeah, what I'm doing to get that pressure head is we've got 20 PSI for the hydrant, and then we got 2.31 feet per PSI. And that's where the 46.2 feet comes from. All right, now that's for C100. Now what we've got to account for a different C is that what we call the equivalent flow is the actual flow times C over 100, right? Now, so the question then becomes, if what is this number here? 1,100. Is it the equivalent or the actual? And what do we want? You know, what do we want to find? And when it says find the flow, what is it that we want?
The actual flow?
Yeah, we want the actual flow. Okay. And anything that comes off those head loss charts is equivalent. So what we're going to have to do is solve that formula for the actual flow. So the actual flow is the equivalent flow times 100. I screwed that up, didn't I? That should be 100 over C. I'm sorry, my bad. There we go. And that would be times, okay, so I had that formula on the top messed up. Had that flipped. So when I solve for the equivalent is when I get this C over 100. Okay. So if I want the actual flow here, I'm going to have to take the 1,100 that I just got, which is equivalent, and multiply it by 140 over 100. The idea is I can get more flow through a C140 pipe than I can for a C100 pipe. Okay? That'll get me more flow.
Is that diameters? Like the 4 gauge diameter?
No, it's how smooth the pipe is.
Okay.
It's just a number, yeah, kind of rates the pipe for how smooth it is. So I'm getting,
The larger the number, the smoother it is?
right, yeah. So I'll get more flow through that slicker pipe. Okay with that? Okay. Last one here. I think I got these numbers pretty well memorized now. All right, so now we're going to put 2,100 gallons per minute through this pipe. And we want to find the minimum required pipe size that we can use. Now, And we have our formula here that the equivalent flow is the actual flow times 100 over C. So what do we got there with the 2100? Is that an actual flow that we really need, or is it an equivalent flow?
Is it actual?
That's actual, yeah. And see, when you go to the charts, you use the equivalent. So when you go to the head loss charts, you use the equivalent flow. So what I would get then is I would take the actual of 2100 times 100 over 140. And that would get me 1400. No, it wouldn't. Yeah, it would. Okay. I'm pretty sure that's how that works. Well, 1500? It's 1500, okay. 1500. I didn't realize that. Oh, yeah, okay, this is 1500.
Nice
Okay.
clean number.
Yeah, right. Okay, so, and then now do the same thing. And remember, the 3.67 is your upper limit. That's as high as the head loss can go. It can't go any higher than that. So,
If I need a gallon per minute, just
hang on a second. Because if we're now what you're doing first, you're taking meter 20 minus 3.62, and that gets you to 33.8. No, it's 320. And see, that's how much head loss. Yeah, that would take you from 320 to 86.2.
so, this is from the smoothness of the pipe.
Okay, so that gets you to 33.8. Now, we have another charts are based on head loss per 100 feet of pipe. So that's why I'm dividing by 9.2, I'm getting that into feet per 100.
Oh, you're taking the
Yeah.
feet per 100?
Yeah, so what I'm saying, I take down 33.8 total feet of head loss. And I can do that over 900 feet of pipe. Yeah, that'll get you the 9.2. 100-foot blanks. Yeah, and actually the 9.2, there isn't any limits on it for feet, you can't.
That's what it is, right? And 367.
Yeah. That's the head loss per 100 feet of pipe. So now you can go to the charts. The charts.
So I take this number?
Yeah, you can use that on charts.
So I take the charts right here.
Yeah. Right.
So, look up
gonna say, okay, I've got 1,500 gallons per minute. Okay, that's 6.25.
It's 100 gallons.
Yeah.
Gallons per minute,
So that's 2 inch head loss there.
it's too much head loss.
Yeah. And look at change pipe. So that's work. So what size pipe can you go with on this one? Yeah, and actually, you gotta go with a pipe. So use the bigger pipe, because that's safer, right? 10-inch pipe, yeah, that's what if they ask me, this question, okay, if we're gonna get 2,100 gallons per minute through that thing and get 20 PSI at the hydrant, what size pipe should we use? I'll say use 10-inch. All right.
And then if it's greater than what number?
If it's greater than 3.67, if it's greater than 3.67, you've got too much head loss. So you can't use that.
Okay. But this one is 3.52.
Well, we're at 1,500 gallons.
Yeah, what does it say that?
Okay, it says 2,100, but C is 140. So we're coming up with the equivalent length. Equivalent flow.
So I take that to 2100.
Well, you multiply it by C over 100, that's it.
Oh, okay.
Get it into what's called the equivalent flow. So I'll get you some of these to do here. What I just handed out to you are some problems that look a lot like what we just went through. And then, let's see. So I gave you a worksheet there. And actually, it's not double-sided this time. Why won't you click in there? You just running a little slow or what? So the worksheet handed out, it's not double-sided, so. I'll get you the answers posted to that, but let's, maybe I don't think there we go. So this will be due Wednesday. We'll cover it Monday. And that's the 8th, right? So do 11.2, 11.3, 11.4, 11.5, I won't assign, 11.6, 7.
This is the 11 that you handed us?
No, these 11 problems are out of the book.
Okay.
And then also this worksheet that I'm giving you
So
too.
10's due on Monday, right?
I'm sorry?
10, yeah, due on Monday.
Oh, let's see. I didn't go over that, did I? Probably should have. Well, let's see. Let's go 10.
I went over some of it yesterday.
That last one's a doozy.
Yeah. Yeah, I'm sorry, I kinda,
What's that? Oh, is it? Okay. Just for fun.
yeah, that one's just for
It
fun.
is, it is an interesting problem, man.
Yeah,
Mm-hmm.
yeah, it's actually pretty good. Tell you what, I'll take questions on this on Monday. Why don't we do that? So I'll push this one back to Monday, or Wednesday.
Chapter 10.
That'll be November 1, that'll be the 8th, right? And then I'll push this one back to Monday, I guess, because I know people aren't here on Friday. So I'll push this one back a little ways. So that'll be Monday, what's that, the 13th, I think?
We on schedule still?
Hmm?
To be on schedule?
Yeah, we'll be okay. So that chapter 10 you can turn in Wednesday if you prefer, okay? And we'll go over it Monday. All right, so we'll call that good.